Hello students of classes 6, 7 and 8. Today I have come up again to discuss with you elements, compounds and mixtures. Now what are elements, compounds and mixtures? Let me first tell you that we know there are various substances around us. Now these substances are classified into two categories. One is pure substance and the other one is impure substance. In the pure substance category, there are elements and compounds, and in the impure substance category, there are mixtures. Now, I'll first start with elements. What are elements? We say that element is a pure substance which is made of only one kind of atom. I'll give an example. I say oxygen is an element and it is made up of only one kind of atom, that is oxygen atom. I cannot say that in the element oxygen, nitrogen atom is present. If I say that, it is wrong. So, element is made up of only one kind of atom. Whichever element you take, it will be made of that particular kind of atom. If it is sodium metal, it is made up of sodium atom. Now, elements, some other things which relate that this is an element. One is that we cannot split elements into further simpler substances. That means if I take element oxygen, I cannot split it further, whether I apply a physical method or I apply a chemical method. Whatever it is, elements cannot be split into simpler substances. Then you have already learned that elements are represented by symbols. I have talked to you before previously that we write symbols of elements and how to write symbol of elements. So elements are always represented by symbol. Next is that elements are further classified. Okay, before I go to this further classification, I'll tell you. So what are the points I just said out here? That elements are made up of only one kind of atom. Element cannot be split into simpler substances. Either I apply a physical method or a chemical method. Elements are always pure. Okay, and another thing is that element is represented by a symbol. Then elements also have a fixed melting and boiling point. Next, I'll come to the classification of elements. Classification of elements means elements are classified into four categories: metals, non-metals, metalloids and noble gases. Now, in the metals category, if I deal with metals, I have to say some properties of metals, properties of non-metals, properties of metalloids and properties of noble gases. Now, here I'll just tell you, I'm not going in detailed explanation of these four categories. I'll just give you examples now. Later, when I'm going to start with metals, non-metals, that will be a separate discussion on the properties of the metals and non-metals. So, in the element category, when I'm saying metals, metals means it is copper, tin. You have seen in your daily life we are using copper wires for electric conduction. So copper is a metal. We use aluminium things. So aluminium rod, aluminium pipe, aluminium sheet. So this is a metal. In the non-metal category, a very common example we are having in the non-metal category is the surrounding air. Air is composed of nitrogen and oxygen. So this nitrogen, this oxygen, they are non-metals. Other non-metals which are there, maybe lower classes will not be acquainted with that, but 7, 8 you will be knowing that in this category of non-metals we have chlorine, we have bromine, we have sulfur, we have carbon. So there are various examples of non-metals. So in the metal category, copper, aluminium, zinc, silver, gold. Silver, gold everyone knows because we wear gold ornaments, silver ornaments. In certain cases nowadays platinum has also come, which is a very costly metal. So these are examples of metals. In the non-metals category, I have said oxygen, nitrogen, chlorine, sulfur, iodine, carbon, etc. Metalloids are what? When I am saying metals, non-metals, metalloids are the category of substances which carry certain properties of metal and certain properties of non-metals. So that comes in that this category of substances come under metalloids. And metalloids example, higher classes will be knowing, class 6 might be not knowing now at present because you are studying chemistry new now. In the metalloid category, we have boron, silicon, germanium, etc. Next, another important classification of elements is noble gases. Now, noble gases means we call them as inert gases. There are 6 noble gases. You have to learn the name of these noble gases: helium, neon, argon, krypton, xenon and radon. Again, I repeat it slowly: helium, neon, argon, krypton, xenon and radon. So these are the 6 noble gases. They are also called inert gases. Why are they inert? Because they don't have the capacity to react with other substances. Hence they are called as inert gases. Okay. So here I close the category of elements here, classification of elements. Let me go to compounds. Now compounds means, first property of compound is that it should be made up of minimum 2 elements, and these 2 elements should be combining in a fixed ratio. Now what is meant by a fixed ratio? Suppose I take a common example, water, H2O. It is seen that in this compound water, hydrogen and oxygen is combined in the proportion of 2:1. So if I prepare water by 5 different methods, in each of the case I'll get water, but the ratio of hydrogen to oxygen, the combination ratio will always be 2:1. So it is said that compound is a pure substance in which 2 or more elements, so minimum 2 elements should be there, 2 or more elements, they are combined in a fixed proportion by mass, or they are combined in a fixed ratio. Here I'll come to another word, that compound is homogeneous, and after that I'll discuss what is homogeneous, and because there are 2 terms, homogeneous and heterogeneous. Next is that compound, we know that when a compound formation takes place, the individual elements lose their properties. Now in what way? I'll give you an example. I have taken the example for water. Let me deal with that only. That in water, hydrogen is present and oxygen is present. Hydrogen element and oxygen, they are actually gaseous. But when water formation takes place, in that case we don't find any gaseous property of hydrogen and oxygen. So ultimately we can come to the conclusion that when compound formation takes place, the elements which are present in that compound will lose their identical, means will lose their individual properties, not identical, they will lose their individual property. That means oxygen supports burning. So do we find that in water oxygen showing its property that it is supporting burning? Because the contradiction comes there that we are using the fire brigade, they use water for putting out fire. So in that case, if they are using water, water is carrying oxygen, so oxygen should support the burning. In that case, the fire will not be extinguished. But what is the other way out? We are saying that the water is extinguishing the fire. That means what? This hydrogen and oxygen, when it has combined to form the compound, it has lost its original property. And oxygen has lost its supporting of the combustion property. Hydrogen also burns in oxygen, that also has lost its property. So water, the compound gets a individual, means the compound which will be formed, that will have its own set of properties. Next is that when a compound is formed, the individual elements of the compound can be separated, means can be regained back only by chemical methods. That means if you want to get hydrogen and oxygen separately out from water, you have to use a chemical process, and in getting hydrogen and oxygen from water, we apply the process of electrolysis, that is a chemical method. And next point is that any compound is always represented by a chemical formula. You have learned chemical formulas previously. I have talked about chemical formulas. So each compound will be represented by a particular chemical formula. So I have listed out 4 points for compound. One is that they are combined in a fixed ratio. The elements lose their individual properties when the compound formation takes place. The elements can be regained back from the compound by applying chemical methods only, not by physical method. Compound is represented by a definite chemical formula, and compounds are homogeneous, I said, and they have a fixed melting and boiling point. This homogeneous heterogeneous part I am going to start discussing when I start the separation technique for mixture. Next I'll come to the next part, what is a mixture. Mixture is a impure substance where 2 or more elements, compounds mix together. They can be mixed together in any ratio. There is no fixed proportion. Mixture is in 2 categories. Mixture can be homogeneous, mixture can be heterogeneous. Just I'll cite out small example. If a mixture is homogeneous, the example is suppose sugar solution. I dissolve sugar in water, sugar gets dissolved, that is a homogeneous solution, because here I cannot identify where is sugar present in the water. That means it is totally uniformly dissolved there. And heterogeneous mixture means if I take sand and stone, suppose, so I can find that this is sand and this is stone. That is heterogeneous. Rest, homogeneous and heterogeneous, detailed part I'll do later. Then in mixture, the elements or the compounds which are there not combined in any fixed proportion, you can take any amount. I'll take a handful of sand, I'll take handful of stone, and I'll mix together. So that becomes a mixture. So in any proportion. When I'm preparing sugar solution, somebody says I'll take 5 spoons of sugar, somebody says 2 spoons of sugar, whatever it is. Water amount, whatever you want to take. So that is the combination process for mixture. Mixture is impure, I have said. Mixture is homogeneous or heterogeneous. Mixture has no chemical formula. Mixture has no fixed chemical formula, and the substances which are present in a mixture can be obtained back by physical method. I'll give a short example. I've taken sugar solution. I evaporate the sugar solution. That means water will be evaporated out. I'll get back sugar or salt solution, whatever. There are other ways also. When I'm going to discuss the separation technique, you will be learning the separation means how the components are separated from a mixture. And since mixtures are combination of any types of things, it doesn't have a fixed melting or a boiling point. So this is the part which what I have discussed today is water elements, water compounds, and water mixtures. So next part will be coming up is that the mixture classification, homogeneous and heterogeneous, and the different separation techniques of mixture, which I'll do in details with you. Thank you. All the best.